Hello everyone. In this lecture we will be discussing about moment of inertia about an axis for a rigid body, and we will derive a concept, or we will discuss something about ellipsoid of inertia. Okay. This will be some algebraic calculations and geometrical calculations here. So here to find we consider some axis which is fixed relative to, say, I can draw like this, or I can also write like this. This is x, y, z. This is an x, y, z coordinate, and we consider any rigid body like this. Okay, this is the origin. We consider any mass point at a coordinate x, y, z, mass m prime. Okay, we consider this is ym is a vector positioning to this, and we consider a vector OQ passing through the rigid body. Okay, the perpendicular projection of this on this axis is P. Okay, so the rigid body is rotating with respect to an axis OQ. Okay, so let the system of Cartesian coordinates Ox, Oy, Oz be fixed related to body, and OQB an axis passing through the body. Okay, and find moment of inertia about OQ. Okay, so here we are considering Cartesian means rectangular coordinate system Ox, Oy, Oz. This is the rigid body, and OQ is axis about which body rotates. M is any point on the rigid body, coordinate is x, y, z. So if you draw from M, if you draw projection on this xy plane, this is xy plane. So suppose this is the point L. So this distance, suppose this cut at it's okay L. So you will get this one. ML, KL, OK. Okay. So OK. So here OK will be, this will be Y. Sorry, this is X. OK will be X. KL, this will be Y, and ML, this will be Z. ML. KL is a projection of M on XYZ axis. Okay. So this is X. This is Y, this is Z. Okay, so this is any coordinate system. Okay, so we have here OK equal to X, KL equal to Y, ML equal to Z for mass point M prime at M XYZ on the body. Okay, so moment of inertia of M prime about OQ. Moment of inertia, we know what is moment of inertia of the mass point M1, mass into perpendicular distance. MP is the perpendicular distance, this square. Now M prime, MP square. Now you triangle this one, so this will be OM square minus OP square. You consider triangle OMP. Okay. Now what is OM square? OM square is x square plus y square plus z square. Obviously coordinate is xyz, so distance will be this. Now what is OP? OP is projection of OM on OQ. This is very important, you should remember. If L equal to cos alpha, M equal to cos beta, and small n equal to cos gamma are direction cosine of a unit vector n cap or alpha cap along OQ, তাহলে alpha cap কত হবে cos alpha I cap plus cos beta j cap plus cos gamma k cap, or you can take Li mj plus nk. Actually, what is direction cosine? Direction cosines are the angle made by the axis with each of the three axes. So now n cap or OQ makes angle alpha with x axis, then x component will be n cap magnitude cos alpha. Yes, alpha cap magnitude cos alpha I cap. So alpha cap magnitude is 1. So cos alpha, because we know if you have some r and if you have x axis and angle is theta, so you have x equal to r cos theta. Now this r, if it has unit magnitude alpha cap, so unit magnitude, so its value will be 1, so it's simply cos theta. Now this component x I cap will be cos theta I cap. So like this cos alpha, L, M, N, these two notations are used. You should remember either L, M, N or cos alpha, cos beta, cos gamma. Directions cosine. So they are called directions cosines, means angle made by the axis with the three perpendicular axes. Okay, so this is projection. So what will be this? What is OM vector? OM vector will be x I cap, y j cap plus z k cap. So what will be the projection of this on that? So this will be projection of OM on OQ is the OP. So we want to find that. So this will be dot product. When we project this one into this, we make a dot product. So dot, so we can write this OP equal to OP square equal to OM vector dot OP vector, OP unit vector square. So this is actually OM vector dot alpha cap square. So dot alpha, if you take dot product of this with this, OM vector is x I cap, y j cap plus z k cap, and OP cap equal to alpha cap, unit vector along OQ vector. So this will be L I cap, M j cap plus N k cap. So what will be this OP? Sorry, this is okay. So this projection, so OP square. So what will be OP square? OP will be projection of this. So OP square is OP vector dot OP vector. Okay. So this will be XL plus YM plus NK square. This is simply, suppose this is equation 1, this is equation 2, this is equation 3. So now you use all the equations. Now if you take OM dot OM vector is this into alpha cap is this. So this will be OP. OP will be projection of OM on OP. So you can make it clear. This is OP. Along this direction we have alpha cap. This is OM. So I want to find MP square. So MP square is perpendicular distance from the axis. So how can I make? I make projection of this. So I have here alpha cap unit vector. So if I take dot product with the unit vector OM vector dot alpha cap, I will get this. Now what is alpha cap? Alpha cap is again given by unit vector. Actually it is along the direction of Q. Okay, so this you remember. So what will be DI? DI m prime into perpendicular distance, that is mp square, that is m prime into om square minus op square. Okay, so this was already we have written. Now m prime into om square is x square plus y square plus z square. Okay, minus what is op? Op was lx plus my plus nz, where lm and are direction cosines, this square. Okay, now you simplify this. Square, here will be a square plus b square plus c square plus 2ab 2bc 2ca, like this. So if you take a square, c square plus y square plus z square minus l square x square minus m square y square minus n square z square. Okay, actually it will be plus all, so minus will be 2ab means lm xy minus 2 mn yz minus 2nl zx. Okay, now you take common, x square common, 1 minus l square plus y square 1 minus m square plus z square 1 minus n square minus 2 lm xy minus 2m yz minus 2n zx. Okay, now m prime, what will m prime? X square, you should remember one important formula of direction cosines, l square plus m square plus n square equal to 1. This is direction quite important. Now you put here l square plus m square plus n square, l square will get cancelled, so here will be m square plus n square. Similarly here it will be n square plus l square plus z square, l square plus m square. Okay, minus rest of the thing will be same. Just simple algebraic calculations you take m prime. So now this is di. Now total moment of inertia, it will be summation, total moment of inertia will be summation of di. So it will be summation of m prime x square m square plus n square plus y square n square plus l square plus z square l square plus m square. Okay, minus rest of the things. Simply write this. Okay, now what you do, you see here I have l square, here I have l square, so I will take l square common. L, m, n are constant which is fixed with respect to the body. So m prime is variable because this is some point. Now if you take l square common, it will be l, m, n all will take a common, so it will be y square plus z square. Similarly if you take m square common, these m and m prime are defined. M prime is the mass, m is the direction cosines, so it will be z square plus x square plus similarly n square if you take, it will be m prime it will be x square plus square plus y square. Okay, minus, now all we will take here common is minus 2lm. What will be the summation? It will be m prime xy. You simply check out minus 2mn m prime yz, am থাকলে y, n থাকলে z, এভাবে থাকবে minus 2 nl, it will be m prime zx. So just এখানে এই যে 2, you see 2lm যদি কমন নেই তাহলে xy m prime xy. So simple, very easy. Now we use this notation ixx l square plus iyy m square plus izz square plus 2ixy lm yz mn zx nl. Okay, where this is a expression for I, general expression for I about an axis which has direction cosine L, M and N. This derivation used to come in the exam. Okay, so you remember this expression. Now where I have used the notation IXS is summation of y square plus z square. Similarly IYY z square plus x square, and I ZZ, right, x square plus y square. So these three are called moment of inertia of a body about x axis, y axis and z axis. So IZZ means the rotation, if that OQ matches with the z axis, then it will be x square plus y square. Okay, moment of inertia about x axis, y axis and z axis. And the other term, that is xy, this is equal to summation of m prime xy yz zx, they are called products of inertia. Okay, they are called product of inertia. With respect to x and y, y and z and z and x. প্রোডাক্ট অফ ইনার্শিয়া মানে কি, এখানে দেখো এক্স এক্সিস আর ওয়াই এক্সিস দুইটা এক্সিসের পার্ট আছে, তো এই জন্য এটা এক্স ওয়াই নোটেশন, ভেরি ইজি টু রিমেম্বার, ওয়াই জেড জেড এক্স, এগুলো হচ্ছে প্রোডাক্ট দুইটা এক্সিসের ক্রসে রোটেশনাল প্রপার্টি। এটা হচ্ছে একটা সিঙ্গেল এক্সিসের ক্রসে এক্স এক্সিস ওয়াই এক্সিস জেড এক্সিসের ক্রসে রোটেশন। এটা হচ্ছে দুইটা এক্সিস, এখানে উইথ রেসপেক্ট টু এক্স এন্ড ওয়াই কত হবে, ওয়াই জেড কত হবে, এখানে দুটো এক্সিস লিঙ্কড, এখানে ইন্ডিভিজুয়াল এক্সিস। ঠিক আছে, প্রোডাক্ট অফ ইনার্শিয়া, এটা হচ্ছে moment of inertia. Okay, so you should remember the steps. First we consider ox, oy, oz, any body m mass xyz, m prime is the mass at the m, p is the any point on that axis, alpha cap is the unit vector which has direction cosine l, m and m. So this is very important to remember. So moment of inertia of this mass point is m into perpendicular distance is mp, then again mp square is om square minus op square. Now om square is simple x square plus y square plus z square, because it is xi cap plus yz z cap plus z cap. And op we find indirectly using alpha cap. Alpha cap has a direction cosine. So op is what, projection of om on this axis. So how to projection, we take dot product om vector dot alpha cap. Om vector dot alpha cap, what is alpha cap? Alpha cap is cos alpha I cap cos beta cos gamma. Okay, so now you know om is x I cap y z cap z cap, you take alpha cap, it will be l x y m z cap square. Okay, m square minus op square, you put this, so then you will get moment of inertia for the mass point m prime. Simply you put, and you use this relation also for algebraic calculations. Now we will find total m summation. Now you take this summation, m will be inside the summation because they are variable, x y z are all variable. What are fixed? L m n. So we take l m and n outside the bracket, whatever possible, 2m n 2l m, all this. And now we simplify by using two specific terms, not two, many specific terms. 6 moment of inertia, one is ixx, iy, izz. Xx is moment of inertia by x-axis is y square plus z square, because we know y square plus z square will be x square. So this is moment of inertia, perpendicular distance will be x square, means it is rotating with respect to x-axis, it is with respect to y-axis, it is with respect to z-axis. Okay, and this product factors, the here actually not, it will be not my, okay, minus m prime xy minus m prime will be there, xy for xy, yz for yz, zx for zx. Okay, these are called products of inertia. This is general relation, you should by heart this formula, because many times in numerical this may be required. Very easy to remember, ixs l square m square n square, these are two direction cosines, and directly with that you have the corresponding, যখন l square থাকবে তার corresponding axis এর রোটেশনটা হবে x axis এর রেসপেক্টে, তখন ixx m হলে y এর সাথে, n হচ্ছে z এর সাথে, because n is the direction cosine with respect to z, and product যখন থাকবে xy, ধরুন lm yz আর yz xy গুলো মনে রাখা সহজ it will be minus m prime তো থাকবে সবগুলোতেই xy হলে xy yz হলে yz zx এই রিলেশনটা মনে রাখবে in next slide we will study ellipsoid of inertia where we will directly use this relation. Okay, let's go to the next slide. Okay, now we move to another important point, that is ellipsoid of inertia. Actually inertia means moment of inertia, some type of geometrical shape. Ellipsoid is some sort of. Now we have the moment of inertia relation. How? Ixx, okay, L square is or cos alpha square it may be, you should remember, m square plus izz n square plus what was the relation? Class 2 factor is there, ixy, it will be L and m for x and y direction, plus similarly I xy yz is m n plus 2 zx, sequentially xy yz zx, and here it will be z means n l. Okay, this is the relation. Now if you take a line segment OH on the axis OQ such that OH equal to 1 by root of I, total moment of inertia. Suppose you have, I already have x, y, z. Okay, now you have some shape. Okay, so this is the origin, say the origin of some shape, and you take h, this OH, and this is this h, and this is some direction. Okay, so on the axis which has L, M, and N is the direction cosine, you take OH equal to 1 by root I. Then let coordinates of H be U, V and W. এটার কোঅর্ডিনেট সাপোজ U, V, W, তো অন্য একটা নোটেশনের জন্য কোঅর্ডিনেট। তাহলে এখন কি হবে, how I will write U? L by root I. Why? You see U, V, W. How will be U, V, W? OH এর একটা ম্যাগনিটিউড হচ্ছে U. Again this direction has L, M, N. So how it will be? OH magnitude is this. Okay, magnitude is fixed. OH magnitude, and this U x component. U means this is the x component. So x component means x component part of this. So unit vector, it has magnitude this. So actually this r vector like this. So it has magnitude is 1 by root I, and r vector component is L. Okay, L I cap plus M J cap plus N K cap. So you should remember this. So x, y, z component will be this. So U, V and W will be this. So from this you find L is U root I, M is V root I, and W is N is W root I. So you modify this. Now you put this in this equation. So L square, M square, N square, Lm all will have root I. So I square root I into root I. Two numbers of root I will be in every. So I take I common. So rest of the things x, L square will be U square I. So it will be U square. Similarly I, Y, Y, V square, I, Z, Z, W square plus 2xy. In terms of LMN, what will be this? LMN, it will be UV plus 2yz VW plus 2zx, it will be WU. So this will be, just you replace all x and y, x, y, z with UVW, and here m factor is root I. Everywhere it will be I, so I is common. So now this gets cancelled. So what we will get? We will get an expression like this. This is the expression. This is equal to 1. This you should remember. So this, what is this? This equation is locus of all points H, OH equal to 1 by root I. Why O is the origin of the coordinate system and origin of the body also. Okay, origin and center of this. Okay, this is a locus of all point eto and represents a surface of second degree, second order surface, u square v square, like this. Okay, now moment of inertia is always positive, so this is a closed surface. Okay, because OH will always be a positive value. Whatever be the I value, I can never be 0. I can never be 0 or negative. Means I is always greater than 0. Okay. As I is always greater than 0, OH is always positive. So if you have some radius, this type of surface are called closed surface. Okay. Okay. So this is, it is called an ellipsoid with this surface equation, center at O, and is called, this surface is an ellipsoid and it is also called ellipsoid of inertia. So if this question is asked in the exam, you should directly put this expression. Now you take the body, you take an intercept, OH equal to 1 by root I is the total moment share. You just put UVW is the coordinate, just change the coordinate. This is a new equation. This equation, how we get this equation? We get, this is the locus of a point. Locus means all the position that we get by 1 by root I. I may be anything. If you take some I for system, and if you put in all direction, you take the locus, it will represent a closed surface of second degree, which is an ellipsoid, and it is called ellipsoid of inertia, as this is related to moment of inertia. Now, what will be the physical significance or geometrical significance? It is asked in the question. What is the ellipsoid of inertia? এটা কি জিনিস? Ellipsoid inertia হচ্ছে সেই পয়েন্ট অফ, সেই H পয়েন্টগুলোর কালেকশন যেখানে OH হচ্ছে 1 by root I, যেখানে O হচ্ছে সেন্টার অফ দ্য ellipsoid and origin, center and origin, both center and origin is O, where OH is 1 by root I. This type of points, all collection of points is represent a surface, closed surface, which we call ellipsoid. Okay, এটা physical significance যদি আমি কি বলতে চাই, with respect to O, which is the origin and center of ellipsoid. ওটা কি হবে? ওটা হবে অরিজিনও হবে, ellipsoid সেন্টারও হবে। ঠিক আছে, এটা কি রিপ্রেজেন্ট করবে? The ellipsoid of inertia. If O is the origin and center of ellipsoid, then ellipsoid of inertia, the body is the locus of all points H for different inclinations of the axis OQ. You see, this is important of ellipsoid inertia. ও যদি সেন্টার হয় এবং অরিজিন হয়, তাহলে এইরকম H এর কালেকশনটা হবে ellipsoid, যেখানে H এর কালেকশনগুলো আমরা কিভাবে পাবো? ওই OQ বিভিন্ন ওরিয়েন্টেশন, OQটাকে সব অ্যাঙ্গেলে ঘোরাই, তাহলে বিভিন্ন দিকে বিভিন্ন H পাবো। তো সেই সব পয়েন্টগুলোকে যদি কালেক্ট করে নিই, তাহলে একটা সারফেস পাবো, দ্যাট উইল বি ellipsoid of inertia. It will be an ellipsoid. So locus of all points for different inclination of the axis of rotation. সব ডিরেকশনে নিয়ে XYZ ফিক্সড, আর এই অ্যাক্সিস অফ রোটেশনটা যদি বিভিন্ন অ্যাঙ্গেল এই সেই ফিক্সড ও এইচ 1/√i ফিক্সডটাকে যদি আমি বিভিন্ন ইনক্লিনেশন নিই, বিভিন্ন অ্যাঙ্গেল নিই, দেন it will give me a closed surface. So this is the importance of ellipsoid of inertia. Okay, so you revise these formulas again, calculations and formula you remember. In the next class we will do angular momentum and kinetic energy for a rigid body. We will find expression for general expression for L we have already written in the earlier session. So in here we will find the value of L for rigid body rotating about an axis and kinetic energy expression. From this we will define various parameters, principal axis, principal moment of inertia, inertia tensor, like this. Okay, so see you in the next session. Thank you.